Good evening. First, we discuss sums given for homework. Now, this is fifth one, exercise 7.6. I think second part, fifth one. Limit x tends to 0, 4x plus 1 upon 1 minus 4x raised to 1 upon x. Now, a upon b raised to m is a raised to m upon b raised to m. What is limit of quotient? Limit of numerator upon limit of denominator. Now same logic, something is added to 1, same thing tends to 0. Index must be reciprocal of 4x. So we write 1 by 4x, but original index is 1 upon x, so raised to 4. In the denominator, we have written minus 1 by 4x as index to get original index back raised to minus 4. Okay. Now this is standard limit. Its value is e. So e raised to 4 upon e raised to minus 4. Simple one. Actually, that is why this was given for homework. But you are supposed to solve these sums. So just listening to explanation is not sufficient. Okay. So what is the final answer? E raised to 8. You have to mention the reason. Since x tends to 0, both plus minus 4x tend to 0, and limit y tends to 0, 1 plus y raised to, this is actually incorrect. They can use alpha, but they will have to write 1 upon alpha and not alpha. Make that correction. Okay. So what is the value of the limit? It is e. Now, sixth one, same. I think this is the fourth sum of this type. Within bracket, take 5 common from numerator and denominator and cancel. Okay. Now, same logic. Something is added to 1. Same thing tends to 0, but index must be reciprocal of this. So in the numerator, see what is done. First, I write what I want. I want 5 by 7x as the required index, but this is not original. To get original, we have to write 7 by 15. See, a raised to m raised to n is a raised to mn. So if you simplify, you get what? 1 upon 3x. Is this the original index? Yes, 1 upon 3x is the original index, right? Similarly, in the denominator, required index is minus 5 by 3x. To get original index back, raised to what? Minus 1 upon 5. Now, value of each limit is e. So e raised to 7 by 15 upon e raised to minus 1 by 5. So what is the final answer? E raised to 2 by 3. Exercise 7.6, third sum. Let L be the limit x tends to 0, 15 raised to x minus 5 raised to x minus 3 raised to x plus 1 upon x sin x. Now you may ask me, sir, can we rearrange the terms in the numerator minus 1 plus 1? No. The reason is simple. Observe the denominator. It is x sin x. We need sin x upon x. Means we have to divide by x square. We cannot just divide denominator by x square. We have to divide numerator also by x square. This means numerator is to be expressed not as a sum or difference, but as product of two exponential functions. See, what is 15? 3 into 5. AB raised to m is a raised to m into b raised to m. See, I think limit is to be used in last step. So this is not actually calculus. This is just factorization, simplification, LCM, trigonometry, logarithm, etc. So take 5 raised to x common from first two terms, you get this. Take minus 1 common from last two terms. Take this bracket common. Yes, we have expressed numerator as product of two exponential functions. Right. So we divide numerator and denominator by x square to get limit x tends to 0, 3 raised to x minus 1 upon x into 5 raised to x minus 1 upon x upon sin x upon x. Now we use theorems. So each limit is now standard limit. So this is log 3 into log 5. I hope you won't say log 3 into log 5 is log 15. No. Log m plus log n is log mn. log m into log n cannot be simplified. So what is the final answer? Final answer is log 3 into log 5. Of course, you have to mention standard limit. It is limit x tends to 0, a raised to x minus 1 upon x is nothing but log a. Right now. Fourth one, let L be the limit x tends to 0, 25 raised to x minus 2 into 5 raised to x plus 1 upon x sin x. Now 25 raised to x is what? What is 25? 5 into 5. So 5 raised to x into 5 raised to x, that is square of 5 raised to x. So you will notice that numerator is square of what? 5 raised to x minus 1. Simple. Now you know what should be done. Divide numerator and denominator. Divide numerator and denominator by what? By x square. Division is defined because x only tends to 0. X is not equal to 0. So this is limit x tends to 0. 5 raised to x minus 1 upon x bracket square. Now I'm omitting one step here. I'm directly writing it. In the exam, you are supposed to mention that. And what is denominator? Denominator is sin x upon x. Originally, it is x sin x, right? And when we divide by x square, we get sin x upon x, simple. So next step again, what is limit of square? Square of limit. So limit x tends to 0, 5 raised to x minus 1 upon x bracket square divided by limit x tends to 0, sin x upon x. So what is the value of this limit? Value of this limit is log 5 bracket square upon 1. So log 5 square is the final answer. I hope you won't say this is 2 log 5. No, 2 log 5 is log of 5 square, that is log 25. It is square of log 5, that is log 5 into log 5. See, in many cases, they use this as standard limit. Limit x tends to 0, log of 1 plus mx upon mx equal to 1. Actually, the logic is this is 1 upon mx log. N log m is log of m raised to n. So this is log of 1 plus mx raised to 1 upon mx. Now, what is limit of log? Log of limit. But note that limit x tends to 0. 1 plus mx raised to 1 upon mx is e. So effectively it is log e, and that is why it is 1. Okay. Now fifth one, limit x tends to 0, 49 raised to x minus 2 into 35 raised to x plus 25 raised to x. Now it is 35, 5 into 7. So this is 5 raised to x into 7 raised to x. I can write 49 as 7 square. Now 7 square means 7 into 7. So 7 into 7 raised to x means 7 raised to x into 7 raised to x. That is square of this. Now see the rule. A raised to mn is same as a raised to nm, right? So 2 into x same as x into 2. So we need this as square of 7 raised to x. So this is 7 raised to x bracket square minus 2 times 7 raised to x 5 raised to x. 25 raised to x will be square of 5 raised to x. Note that numerator is square of 7 raised to x minus 5 raised to x. But again within bracket, subtract 1 and add 1. See, because we need exponential function in which form? A raised to x minus 1. That is why. Okay. Yes. So 7 raised to x minus 1 minus in bracket 5 raised to x minus 1. Denominator as it is. Now next step, divide numerator and denominator by x square. So this becomes 7 raised to x minus 1 upon x minus 5 raised to x minus 1 upon x. Sin x upon x, log of 1 plus 2x upon x. Next step. See 1 plus 2x, and that is why this x is written as 2x, but we cannot just multiply denominator by 2. We have to multiply numerator also by 2. Now take the limit. So in bracket log 7 minus log 5 bracket square upon 1 into 2 into 1. It is better if you prove that value of this limit is 1, as we have discussed just 2 minutes before, right? So this is log 7 by 5 square, half into square of log of 7 by 5, because log m minus log n is log of m upon n. See, they have mentioned this. Limit alpha tends to 0, log of 1 plus, it is better if they say m alpha, because coefficient of alpha, or in this case x, is not 1. If it is m, it must be repeated, right? So this is the final answer. Now we discuss limit at infinity. See, what is infinity? Infinity is something which is greater than every real number. So clearly infinity is not a real number, and therefore it cannot be shown by a point on the number line. We know this. So this is plus infinity. Similarly, we have minus infinity. What is minus infinity? It is something which is less than every real number, but again it is not a real number, and that is why it cannot be shown by a point on the number line. Now here we use this standard limit. It is quite logical. Limit x tends to 0, 1 upon, extends to infinity, not 0. Limit x tends to infinity, 1 upon x equal to 0. This is quite logical. If denominator approaches a very big number, its reciprocal approaches 0. For example, what is 1 upon 1? It is 1. What is 1 upon 10? It is 0.1. What is 1 upon 100? It is 0.01. Actually, 100 is not such a big number, but 0.01 is close to 0, right? So when x approaches infinity, 1 upon x approaches 0. So which standard limit is to be used here? The standard limit to be used is this one. It is limit x tends to infinity, k upon x raised to p equal to 0, where p is greater than 0. K belongs to R. K is a real number. K not equal to 0. Okay. Yes, or in some cases K is 0, but 0 into any real number is 0. Don't say 0 into infinity is 0, right? So in that sense, I'm saying that usually K is not equal to 0. Now this is quite logical. Why to say P greater than 0? Because if I say P is minus 1, then this becomes 1 upon x raised to minus 1, that is x. So limit of x as x tends to infinity is infinity. This means denominator should be positive power of x, right? And you can use this as standard limit. So the working rule is simple. You have to divide. For example, I will give one function. Limit x tends to infinity. Say x cube minus x square plus 1 upon 2x cube plus 1. Working rule is simple. Divide numerator and denominator by the highest degree term in the denominator. In the denominator, highest degree term is x cube. So if you do so, then this is 1 minus 1 upon x. What I'm doing, I'm dividing numerator and denominator by x cube, right? What about denominator? 2 plus 1 upon x cube. Can I take the limit? Yes, I can. So this is simply 1 minus 0, because this standard limit, plus 0 divided by 2 plus 0. So what is the final answer? It is nothing but 1 upon 2. Okay. Exercise 7.7, first part, first sum. Let L be the limit. Limit x tends to infinity. Ax cube plus bx square plus cx plus d upon ex cube plus fx square plus gx plus h. See, function is of which type? F of x upon g of x, where f and g are both polynomial functions. So in such cases, we divide numerator and denominator by the highest degree term in the denominator, which is x cube. So if you do so, then you get this. Now we can take the limit. In fact, I will directly write L equal to a plus 0 plus 0 plus 0 divided by e plus 0 plus 0 plus 0. So what is the final answer? It is a upon e. Of course, I have to mention the standard limit. Limit extends to infinity k upon x raised to p equal to 0 if p is greater than 0. Right now. So final answer is a upon e. Second sum, let L be the limit. Limit extends to infinity x cube plus 3x plus 2 upon x plus 4 into x minus 6 into x minus 3. Divide numerator and denominator by x cube. So this is 1 plus 3 upon x, rather x square, plus 2 upon x cube. Now in the denominator, I give x to each of these three terms. So what will be the next step? What is x plus 4 upon x? Split numerator. So it is within bracket 1 plus 4 upon x. Here 1 minus 6 upon x, and here 1 minus 3 upon x. Right. Right. Now take the limit. So this is 1 plus 0 plus 0 upon 1 plus 0, 1 minus 0, 1 minus 0. So the value of limit is 1 upon 1, which is nothing but 1. Of course, you have to mention the standard limit. Limit extends to infinity k upon x raised to p equal to 0. So why to mention k? Otherwise, we'll have to say 3 into and then 3 into 0 equal to 0. This enables us to write 0 directly. And what is p? Restriction on p. P has to be greater than 0. Here p is 2, 3, 1, 1, 1. So final answer is 1. Second part, first sum, let L be the limit. Limit extends to infinity 7x square plus 2x minus 3 upon root x raised to 4 plus x plus 2. Now divide numerator and denominator by root of x raised to 4, that is x square. See what we get. So L equal to now limit extends to infinity 7 plus 2 upon x minus 3 upon x square. See, dividing by x square means dividing by root x raised to 4. I'm writing this directly. X raised to 4 plus x plus 2. Okay. Now in the next step, split numerator and then take the limit. So it is limit extends to infinity 7 plus 2 upon x minus 3 by x square. I have already told you that dividing by x square means dividing by root x raised to 4. Root a upon root b is root of a upon b. Split numerator. So if you take the limit 7 plus 0 minus 0 upon root of 1 plus 0 plus 0. So 7 is the final answer. If you do not mention this result, you won't get full marks. Limit extends to infinity k upon x raised to p equal to 0, where p is greater than 0. Second, let L be the limit extends to infinity, root x square plus 4x plus 16 minus root x square plus 16. You have to rationalize numerator, that is multiply numerator and denominator by root x square plus 4x plus 16 plus root x square plus 16. So on rationalizing, we get 4x in the numerator because a minus b into a plus b is a square minus b square. So 4x upon this. Divide numerator and denominator by x. X means root x square. So 4x upon x is 4. And here root a upon root b is root of a upon b. Split numerator and so on. Yes, so we get limit extends to infinity 4 upon root of 1 plus 4 by x plus 16 by x square plus root of 1 plus 16 by x square. Now we have to use this limit. Limit extends to infinity k upon x raised to p is 0 where p is greater than 0. So this is 4 upon root of 1 plus 0 plus 0 plus root of 1 plus 0. That is 4 upon 2, which is 2. So 2 is the final answer. Now the next one, limit extends to infinity root of x raised to 4 plus 4x square minus x square. See, if you say this is x square plus 2x and then obviously answer is wrong and you will blame calculus. That is ridiculous. How can you simplify this? Root x raised to 4 plus 4x square. At the most you can say take x square common to get x in bracket root x square plus 4. Okay. See, rationalize numerator, simple. So a minus b into a plus b, a square minus b square. So we get simply 4x square. Now usually we say divide numerator and denominator by x square. Here they have done the same thing but in different form. Within radical sign they have taken x raised to 4 common to get 1 plus 4 upon x square. Now root x raised to 4 is x square. Now don't ask me why not plus minus. In function by root we mean positive root. Otherwise it will be 1 many. 1 many is not a function, right? So this is 4x square upon x square into this plus x square. Divide numerator and denominator by x square to get 4 upon root of 1 plus 4 by x square plus 1. Then limit of quotient and so on. See, they have directly taken the limit. Have they put x equal to infinity? See, infinity is not a real number. So when x approaches infinity, constant remains constant. That is why it is called as constant. It is not a variable. Now when x approaches infinity, 1 upon x square approaches 0. Simple. So what is the answer? I'm sorry. What is the answer? Final answer is 2. Let me explain. Second one, third part, second one, limit extends to infinity 3x minus 4 cube into 4x plus 3 raised to 4 upon 3x plus 2 raised to 7. See, 3 plus 4, 7, in the denominator also 7. So we divide numerator and denominator by x raised to 7. How to split x raised to 7 in the numerator? By writing it as x cube into x raised to 4. You may ask me reason. I'll say common sense. This is a cube, this is fourth power. That is why x cube x raised to 4. As simple as that. Now, 3x minus 4 cube upon x cube is a cube upon b cube is a upon b cube. So 3x minus 4 upon x cube, 4x plus 3 upon x raised to 4, 3x plus 2 upon x raised to 7. Now split numerator. Now take the limit as x tends to infinity, 1 upon x tends to 0. So you get 3 minus 0 means only 3. 3 cube into 4 cube upon 3 raised to 7. I usually directly write 0 for this because we do not mention this result. We say it is k upon where k is constant, right? So this is 3 cube into 4 raised to 4 upon 3 raised to 7. On simplification, 256 upon 81 is the final answer. So L be the limit, third one, limit extends to infinity, root x into root of x plus 1 minus root x, multiply numerator and denominator by root of x plus 1 plus root x. So this is root x into x plus 1 minus x, that is simply root x into 1, that is root x, denominator as it is. Now working rule is simple. Highest degree term in the denominator, x raised to half, that is root x. So divide numerator and denominator by root x. So when you divide by root x, you get this 1 upon root of x plus 1 upon root x. Root a upon root b is root of a upon b. So on simplification, it is just root of 1 plus 1 upon x. Take limit. So it is 1 upon root of 1 plus 0 plus 1. That is half is the final answer. Now this is the last sum for today's lecture. Let L be the limit. Limit extends to infinity. 2x minus 1 raised to 20 into 3x minus 1 raised to 30 upon 2x plus 1 raised to 50. Divide numerator and denominator by x raised to 50. Right? So in the numerator, you have to split x raised to 50 as x raised to 20 into x raised to 30. Now it is a raised to m upon b raised to m. It is a upon b raised to m. Use that and simplify. So effectively this is what? 1 minus 1 upon x raised to 20 into 3 minus 1 upon x raised to 30 upon 2 plus 1 upon x raised to 50. Limit of this as x tends to infinity. Now this is simple. If you take limit, then it is just 1 raised to 20 into 3 raised to 30 upon 2 raised to 50. In fact, it is not 1. I'm sorry, this should be 2, not 1. So 2 raised to 20 into 3 raised to 30 upon 2 raised to 50, because limit extends to infinity, 1 upon x equal to 0. So it is 2 raised to 20 into 3 raised to 30 upon 2 raised to 50. That is 3 raised to 30 upon 2 raised to 30. Finally, 3 upon 2 raised to 30. Of course, we have to mention this reason.